In the last video, we saw how to combine rational expressions that had a common denominator, and they followed all the regular rules of fractions. If the denominator is the same, just keep the denominator, and then just either add or subtract the numerator to the top. Now, we're doing the same thing here, but we've got a really important trick that we're going to see as things are going to get really hard when these denominators are not the same. So there's a really valuable trick that we need to see. I have 3u minus 1 here and 1 minus 3u. That is so very close to being the same thing, but it's not quite the same. Now, the way I do this with a little lesson, a little warm-up lesson, if I had this and I asked you to FOIL this out, you'd send a negative 1 through here and I'd now have negative 1 plus x. Now, I could write this the other way around. Isn't that the same as x minus 1? So look what's happened. By this negative 1 has flipped 1 minus x the other way around. Do you see what I'm saying? So if you pull out, you could go the other way. If you pull out a GCF of negative 1, it will turn something. It will flip it. So let me show you what I mean. Let's take a GCF out of this of a negative 1. Okay? Taking a GCF of a negative 1. When I do that, doesn't it change the signs of everyone who follows? So by pulling a negative 1 out, we saw this in our factoring section. If I take a negative 1, it's going to change everybody's sign. So if you're not sure about that, send them back in. Negative 1 times 1 is positive 1. Negative 1 times 3u would be negative 3u. So here's what I'm saying. The trick is this. If you pull out a negative 1, it will flip it around. Do you see what I have here is really 3u minus 1? It flipped it. Now this only applies to subtraction, but if you have a subtraction one here like this, and it's the wrong way round, we can pull out a negative 1 and that will fix it. It will flip it. Now the book will show this as literally as a negative 1, but a negative 1 and just a negative sign are the same thing. And so what I'm going to do is I'm going to take out a negative sign, and what I'm going to do is I'm going to put it right in front of this fraction here. So let me show you what I mean. If I take a negative sign out of this bottom here, right out of there, I'm going to put it in the front. Well, there was a plus sign there, but I'm going to replace it with that negative sign that I just took. And when I do, it's going to flip it around. So again, this is a very important trick and very strange. So here's what I'm saying. By taking a negative out of this, it flips it around. And now it matches like I want it to match. They are now the identical denominator. But that negative that I took out, I'm going to put it in the front of the fraction. Now there was a plus there, but I'm going to make it a minus because that's the negative that I took out. So if I want to flip this, put a minus out front and it will flip it. It will fix it. Now they have a matching denominator, so I've got 4u minus 1 minus u. It's going to be 3u minus 1. Oh wow, look at that. I don't like this. Gets you 3u minus 1 over 3u minus 1. Now that's identical numbers. Those are, the entire number is a match, so you could cancel that down and you would just get 1. I think that's a bad idea to do that little trick right there, but so let's do another one here. These are so close to being the same thing. Well, let's flip it around. But if I do, that means I've put a negative in front. Now I'm replacing the plus sign with that negative. And now, though, it's flipped around the right way. So now it matches. My little trick has now made them match. So now I'm doing 8x minus 15 minus 2x. That's going to give me 6x minus 15. And the denominator matched, so it stays the same. Now I'm going to pull out a GCF out of the top. It's a 3. So I've got 2x minus 5 over 2x minus 5. So these are now factored. This is a factor and that's a factor. They can be canceled. My final answer is just 3. Okay. Try this again. Nothing changes here. It's the same trick. I want to flip this around, so I'll put a minus in front. And when I do, that has fixed this. It has flipped it around. Okay, now we have a common denominator, so we can just do 4y minus 7. But this negative, remember, this will get missed by a lot of people. This negative has to go all the way through. So I'm going to just write it here with all different signs. It's going to change all of those signs. So let's do our common, or our like terms. 6y squared minus 2y squared is 4y squared. 7y and minus 2y is 5y. Negative 10 and negative 11, negative 21. Okay. Now this would require the AC method, but I think we need to try it because I think it can be done. So I have a feeling that something is going to cancel with the bottom. So I'm going to try to see. I'm going to just see. So I'm going to do the guess and check. Try the AC method if you want to do that, but I'm going to guess that this is going to be a common term. So this would make this 3. So I'm doing the guess and check approach here because I have a feeling that it will be a match. No, it doesn't work. Oh, yes, it does. 12, yeah, it does. So again, you could do the AC method and look back if you had trouble factoring this, but I was doing the old guess approach because I knew that it was probably going to have a match. So if I knew one side, I kind of just figured out what the other one would have to be to make everything work. So those cancel, and I get y plus 3. Okay, I've got the same problem, but now there's already a negative out front. So this is pretty clever too. I want this to flip around. Okay, if I want to flip it around, I'm going to take out a negative sign and put it in the middle. But there's already a negative sign in the middle. So that would put 2 negatives in the middle. Well, 2 negatives become a positive. So let me show you what I mean. So I want to flip this around. But to do that, I need to put a negative in the middle. There's already a negative there. So 2 negatives make a positive. Okay, so I fixed it. And now it has become an addition problem when I flipped it around, which actually makes it easier. So I've got my common denominator now. We're just going to add this up. I've got m squared minus 3m plus 2. Okay, now let's factor these to see if we can cancel anything down. I have m minus 2, m minus 1 on the top. On the bottom, m plus 1, m minus 1. And I did, I had a match. So those cancel, and that would be my final number. Okay. I need my trick again. This is the wrong way around. So I'm going to fix that. But if I do, it puts a negative in the middle where there's already a negative. So 2 negatives make a positive. Okay, denominator is the same. So we can copy that over. Now let's combine stuff. Y squared minus 5y. I got negative 5y plus 6y. That's going to be 1y minus 6. Okay, time to factor. And this one is. Now, they're factored. The factors can cancel. Let me see. Yeah, last one here. So this is a little harder with the trinomial, but I think it's going to work out okay. I'm the wrong way around on the back end. So let's try this. So spin that around, and now it would be n squared minus 1 like I want, but a minus comes to the middle where there was already a minus. So now it's become an addition problem. Okay, the denominator's fine now. So let's put this together. I've got 3n squared plus 1n minus 2. Now, I don't usually do the guess and check approach, like where you just try to figure out if you can build it. And this one would actually, I think, be an easy one too. But let me do the AC method just to show you again. So you remember the way you did that is 3 and negative 2 make negative 6. So now we're looking for two numbers that make negative 6 and add to be 1. So that'd be 3 and negative 2. So I'm going to make this 3n squared plus 3n. Remember, you then break that middle up into those two numbers. Now once you've done that, GCF of the first two. And on the back, the GCF is a negative 2. If it starts with a negative, you always take that. So I would get this. Now this is not factored. The n plus 1s are a match, so I've got 3n minus 2 times n plus 1. Okay, now it's factored. Now let's factor the bottom. That's the perfect square binomial. Now we can cancel the matching factors and we get that for our final answer. Okay, so that is a very, very useful trick, and we had a whole section on that, so if you can get that trick down, it'll be super helpful as we move to our next section where we do not have common denominators and we've got some extra tricks we got to do.